Hey everybody, welcome to another Cone support video. This time we are working on writing proportional equations from tables. So I just set some information up for you here. So you got a table, right? It's going to be input output table, x, y. The unit rate is wherever x is 1, right? And the outputs for every one input. You've got your k, which is your constant proportionality or your unit rate or your multiplier. And it's going to be the ratio of y over x. In the equation, it's going to be what you multiply the input by to get the output every single time. So we're going to use this information to help us solve these problems. All right, so let's go. So it says on a set of steps, the first step from the base of the steps is labeled 1. The second is labeled 2, and so each step has the same height, so it's proportional. The table below shows the step number and steps height from the base of the steps. All right, so it really doesn't matter which is which, but I would say that step number is going to be probably the input value, and I would say that the height would be the output value. So let's put step number as the input, and that means we're going to put the height in meters, as your output. Okay, so that's going to be a relationship, which means that when you're doing your k, it's going to be height in meters on top, and it's going to be the steps on bottom. And so basically step number on bottom. So this tells you the height per steps, basically, the height per step. So that makes sense. That's the unit rate we're looking for, height per step. So it tells us here that when at step number 50, so when input 50, right, you're going to get an output of 10. And so if we divide top and bottom by 50, we're going to get our unit rate. And so we can see 50 divided by 50 is 1. And 10 divided by 50 is 1/5 or 0.2. So what it tells you is you're getting 0.2 meters for every step. So the unit rate is going to be 0.2 meters for every step. And we can just fill out the table a little bit if we want to. We can see that at step number 50, that would be a 10 divided by 5, basically, times 5.2. And then 90 would be 18. 90 divided by 5 is 18. 90 times 0.2 is 18, and so on and so forth. The equation for this is real simple. You take your unit rate, 0.2 over 1, which is 0.2. That becomes your constant. That's your k. And so you just write y equals 0.2 times x. Anytime you have the input of steps, you times it by 0.2 or 1/5, and you get the output of height. Okay? So that's equation. Write an equation that describes the relationship between n, the step number, and h, the height from the base. Okay, so they want to change x and y to n and h. They say that n is going to be the step number. So, okay, let n equal the step number. And that means that h is going to be the height. Let h equal the height. So that's kind of sloppy looking. Let's write that there. N and h. All right. So that means that our x is going to be replaced with n in our equation. So it's going to be 0.2 times the number of steps, and that's going to equal h, our height. So there's our equation. We just replaced the n with x, or the x with n, and the y with h. It's the same exact idea, input output, just they changed the variables for input and output. All right, so let's put it in. It's going to be h is equal to 0.2 n. That's how we do it. All right, let's do the next one. Pause it so I can reset everything. All right, we're back. The following table shows a proportional relationship between W and Z. W and Z. So we know we're going to have a W and a Z here. So I'm just put W. Actually, I don't know which is which yet. Let's just leave it. Write an equation that describes the relationship between. You know what? It doesn't really matter. So because it doesn't make a difference, you could call it either way. Just whatever you do, just do it. So W is going to be my X and Z is going to be my Y. It doesn't matter which is input and output. Generally speaking, you read it left to right if there's no indication of what these things mean. So the first one's X, the second one's Y, generally speaking. All right, so let's do it. So we got our W values, which are X values, our inputs, and we got our Z values, which are our Y values, our outputs, right? All right, so this one says that our table is going to be then when W is 18, I can't see it right. W is 18, our Z is 2. When W is 45, our Z is 5. And you could keep going, right? We don't need to. So I have the relationship here. I think it's pretty clear what it is. So when W is equal to 18, that's going to be our input. All right. Our output is 2. And when our input is 45, our output is 5. All right. So you could think about it this way, and that's fine if you think about it this way. So these should be equivalent ratios if it's a proportional relationship. So let's see if it is proportional. So 10 times 5 is 50, and 8 times 5 is 40, so that's 90. So this is a product of 90. This is also a product of 90. 2 times 45 is 90. So the cross product is true. These are proportional relationships, all the rates staying constant. In other words, 18 divided by 2 is 9, and 45 divided by 2 is divided by 5 is 9. The other way around, 2 divided by 18 is 1/9, and 5 divided by 45 is 1/9. So the ratios are all staying the same. And you could write this equation in multiple ways depending on what you chose as your input and your output. I chose W as my input and Z as my output. If I chose that, then this is the ratio I'm working with. And I can see that if I were to divide any of this, I'll get the same result. So let's just divide top and bottom by 45 here. And that way you guys can see kind of what the unit rate would be. So when I divide top and bottom by 45 here, you're going to get 5/45 or 1/9 for every 1. So my unit rate here, in the way I set my problem up, would be that if Z is your output and W is your input, the equation would be that your output, Z, is equal to 1/9 of your input. Now that's one way to write the equation. If you wanted to, you could flip the relationship, right? And if you flipped the W and Z components, right, instead of it being every 1 W, sorry, I put the Y there. Why did I put Y there? That's weird. Sorry. So, yeah, I don't know what I was doing there for a second. So that was silly. So the input is going to be W, right? So we're going to do 1/9 times W is equal to the output of Z. All right. So this is one way to write the equation. That every Z is equal to 1/9 of the W. So you take the W, times it by 1/9 to get the Z. Take the W, times it by 1/9 to get the Z. So this would work as an equation. Put that in, it's going to be the right answer. All right. But you could also, like I said, flip the relationship if you wanted to, right? And you could then just flip the multiplier. So if you change your inputs and your outputs, right, that means that W would be equal to 9 times whatever Z is, right? So you take the Z, times it by 9, get the W. Take the Z, times it by 9, get the W. That would also work. Either of these equations would be correct. If you put either one in, you're going to get it right, okay? I'm going to use this one because this is what I originally started with, right? This is the relationship I chose where W was my input and Z was my output. So that's what I'm going to put. So Z is equal to 1/9, 1/9, and then W. So times W. And that's going to be right. Like I said, you could also have written W equals 9Z, and it would be correct as well, as long as you're being consistent. Okay, guys, I'm back. I set the problem up so we can just see it quickly. So it says the following table shows proportional relationship between M and N. So I'm going to say M is our input and N is our output. Like I said, it doesn't matter what you choose in this case as input and output. It just changes the equation that you're going to get, right? So in this situation, I'm going to do M as my input and N is my output. So that means the ratio of N over M is my constant, my multiplier. Okay, so we know that when N is 21, M is 3. When N is 21, M is 3. So that means our unit rate, okay, would be divide top and bottom by 3. And you're going to get the ratio there of 7 to 1. Okay, so that means when M is 7, okay, when M is 1, N is 7. Okay, so that means 7 N's for every 1 M. So the equation for this would be y equals, or it's not y equals, is it? It's the output, which in this case is N, is equal to the ratio of output to input, which is in this case 7, the unit rate, times the input, which is M. So it's output equals a constant, output over input, times the input. Okay, and that's kind of what you're going to get. So this is the equation you would put here to get the correct answer. And just check it to see if it works. When you input a 3 for M, 3 times 7 is 21. You get an output of 21. When you input a 5 for m, you get 7 times 5, which is 35. Output of n, which is 35. And then if you input an m value of 8, you get 7 times 8, which is 56, which is the output value, right? So that works. We know this is going to work. The other way you could have written it is you can do the reciprocal of the k and just flip the relationship, right? So if we just flip input and output variables, what would that look like? Well, instead of it being n equals something times m, it would be m equals something times n, and you just flip the 7 to its reciprocal because you just flip the relationship, right? So the two equations you could write for this are either n equals 7m, or if you change your input and output, right, you're inputting an n and outputting an m, then it would be m is equal to 1/7 of n. And that makes sense, right? If you take the n and you times it by 1/7, you get the n. Just basically divide by 7, right? So either one of those equations will work. I'm going to choose the n equals 7m. So n equals 7m, and I'm done. All right, now let's go to the next one. I'm going to reset everything for you. All right, so in this one, it says that the following table shows a proportional relationship between j and m. Once again, they have no information here, so it doesn't matter what you pick as your input and your output. I'm just going to make j my input and m my output. Okay. Fill out my table here. I can see that when j is 4, m is 3, and j is 12, m is 9. Okay. So I'm just going to pick this relationship here that when j is 4, the m is 3. Okay, so input 4, output 3. So that means the ratio of output to input is going to be 3/4, which is already basically a unit rate, but I'm just going to show you the process. So you can divide top and bottom by 4, and you can see that to get your equivalent ratio, what you get is 3/4 for every 1, right? So that means that the relationship here is 3/4. So if you take your input, you times it by 3/4, you get your output. 1 times 3/4 is 3/4. 4 times 3/4 is 3. 12 times 3/4 is 9. Fair enough. So your equation would be your output, m, is equal to 3/4 times your input, j. Now that is one equation you can use to solve for this. The other equation you could use to solve for it is to just reverse the relationship basically in terms of what was input and output. So this time you'd start with a j, you would, you'd end with a j, output would be j. You would start with the m, and you'd multiply that m by not 3/4, but the reciprocal of 3/4, 4/3. So you could have written, depending on what you chose as output and input, you could say that the relationship is j equals 4/3 m, or you could say the relationship is m equals 3/4 j. All you got to do is just take the constant and flip it top to bottom, right? Depending on whether you're having, j as your input or j as your output, you choose. I originally chose input of j, output of m, so I think this is the one I'm going to put in, right? And it works, right? We already know it works. If you input the 4, right, you're going to times it by 3/4, you get the 3. Input the 12, times it by 3/4, you get the 9. Input the 20, times it by 3/4, you get the 15. It works throughout the entire table, and the ratio of input to output is always 3/4 in my case. And so this would be the equation m is equal to 3/4 3/4 times j. Okay, so that's it. If you were to do the ratio of output to input, m over j, throughout the entire table, you'd always get 3/4. And that's how you do the problems.